We found our roots. We sketched those on the graph. We found our h values, so we know the x part of the vertex. We still need to find the y part of the vertex. So we're going to substitute back into our function, f of 4 is equal to negative 2 times 4 squared plus 16 times 4 minus 26. All right, so a piece at a time. 4 squared is 16. What is 16 times 4? 64 minus 26. So I have negative 32 plus 64 minus 26. What do we get? Negative 32 plus 64. I'm sorry, how much? 6, yes. All right, so here is our k value. Is this going to be a maximum or a minimum? Maximum. How do we know? A value is negative. So we know that it opens down. So our parabola is going to look like this. That means our vertex is a maximum up here. With the way your homework is set up, the way Canvas is set up, because this is the way IU wants to make sure you can understand, recognize, and write a maximum or a minimum value. When I go to write this maximum, I have f of, what did we substitute in to get the output of 6? 4 is equal to 6. This gives me the x and the y. Here's the x. Here's the y for my vertex. So that's how you need to type it into Canvas. F of whatever the x part of the vertex is equals whatever you found as the output, so the y part of the vertex. So I'm going to go and sketch that on our graph. 4, 6, so right up here. And I'm going to trace through those x-intercepts that we sketched yesterday to get our parabola here. So far, so good? All right. That's good to hear. All right, we're going to switch gears a little bit and actually revisit something that we did earlier that you guys all thought was pretty easy. At the beginning of this section, I gave you a vertex and I said, write the equation for any parabola that has this vertex. And so we left A in our equation. Do you guys remember doing that? Not right now? We're going to write the equation for a specific parabola. We know the vertex, and we know one other piece of information about it. Yep. Remember, IU and your book use standard equation to mean vertex form. So AHK form. And since they gave us the vertex, what did they give us already? They gave us H and they gave us K by giving us the vertex. So I'm going to take the H and the K they gave us, and I'm just going to substitute it into vertex form. We still need what piece, though? We still need A. What else did they give us to work with? They gave us a point that it passes through. So we're going to take this point that it passes through. We're going to sub this in for x and y. And we're going to use that information to find our a value. So I'm going to put 25 in the place of y. I'm going to put 3 in the place of x. And then I've got that plus 2 on the end. And don't forget to square my parentheses here. What is 3 minus 0 squared? 9. So I have 9a plus 2. Where'd I lose it?
Why is it plus and not minus?
Wait, is it supposed to be plus 2?
Nope, it's supposed to be minus 2. Thank you.
Oh,
Thank you. You guys caught my mistake. Thank you. Where do I go from here? Add 2 to both sides. So I get 27 is equal to 9a, which means a is what? A is 3. That was the last piece of information that we were waiting on to be able to write this in AHK form because they gave us H and K. So what would my final answer be then? Y equals, yep, 3x squared or x minus 0 squared minus 2. Let's try another one just like this one.
Wait, could you leave it as x minus 0 squared, or do you have to simplify it out?
So if you had it like this, it wouldn't be wrong, but it wouldn't be considered fully simplified. So good question. All right. I'm going to put the next one up on the screen, and I'm going to give you guys about a minute and a half, 2 minutes to work on it yourself. Same exact idea as this problem here. What does this look like just as I initially set it up with the given information?
Y equals a parentheses x minus 3 squared plus 1.
Yes, x minus 3 squared plus 1. And then they gave us one other constraint that we are supposed to use so that we can find a. What did they tell us? The x-intercept is 0. So the point that they gave us, even though they didn't specifically state it because they gave me the x-intercept, what is our point? 0, 0. So this is what we're going to sub in for x and y. So 0 in the place of y, 0 in the place of x, and away we go. 0 minus 3 squared, 9. So I have 0 equals 9a plus 1. Subtract 1 from both sides. I get negative 1 equals 9a, which means a is what? Negative 1/9. So that was the last piece we were waiting on. We take that and substitute it in. So final answer here, y equals negative 1/9 times x minus 3 squared plus 1. How do we feel about that? Pretty reasonable? Awesome. All right, there is a question on your homework, and I've already gotten several emails about it because you're right, we haven't done any examples like this yet. Finding the maximum vertical distance between the parabola and the line for this green region. We want to find the maximum vertical distance. There is more than one way I can go about doing this. The most straightforward way with the fewest number of steps. Which of these shapes is on top, the parabola or the line? The parabola. So if I want to find the distance between these two, I'm going to take the parabola, the one that's on top, and I'm going to subtract the line. Parabola minus the line. Since I'm wanting the maximum, after I subtract these two, I'm going to go and look at the vertex. Look at the vertex of our new function, and because I want the vertical distance, should I look at the x part or the y part? The y part. All right, so they gave us the equations to work with here. Here's f of x. And down here is the linear function, so quadratic or parabola minus line. So my parabola is negative 2x squared plus 4x plus 3 minus my linear function. If I am subtracting something, what do I have to watch out for and be careful about? Make sure you distribute the negative. So I'm going to have parentheses before I write down x minus 2. So I'm going to distribute that negative. So I have minus x plus 2. What is my result going to be now? Negative 2x squared plus 3x plus 5. This is the function that describes the distance between my parabola and my line. This one is on top, and this one is on the bottom. If the line was on top and the parabola was concave up, then I would do my subtraction the other way. It's always whatever function is on top minus whatever function is on bottom. So here's my new function. And so this is what I want to find the vertex of. How do I find the vertex for this?
B over 2a.
Yes, so we're going to do our axis of symmetry. X equals negative b over 2a. What are we using for a, b, and c here? What is a? Negative 2. What is b? 3. And c? It's 5. All right, so we're going to substitute in negative 3 over 2 times negative 2 so I have negative 3 over negative 4, which simplifies to what? 3/4. So here's my h value that we need to substitute back in to the equation, this new function here. Let me draw a line here. We're subbing into our new function because I want the y, the vertical distance between these. So I have negative 2 times 3/4 squared plus 3 times 3/4 plus 5. What is 3/4 squared? 9 over 16. So I have negative 2 times 9 over 16 plus this one's going to come out to be 9 over 4 plus 5. Again, what we are finding here is the distance between these. What is negative 2 times 9 over 16? Negative 18 over 16. Will that reduce at all? Instead of negative 18 over 16, I can write that as negative 9/8. I need this common denominator so that I can combine my constants together. How could I rewrite 9/4 with a common denominator? 18 over 8. And what about 5? It would be 40 over 8. It would be 20 over 4, but because I have the over 8s, because I can't reduce that one at all, I'm going to put it over 8. But yes, you were absolutely correct. What do I get when I simplify that? (49 over 8). So this right here is our maximum vertical distance. To find the distance between two things, I need to subtract them. We ended up with a parabola when we subtracted those two functions, and since I wanted the maximum, We went after the vertex, and I wanted the y part of the vertex since I wanted the vertical distance. So far, so good? Right. There is one more problem, and then we finish out 3-6. Very similar to the ones we just looked at a moment ago, where they gave us the vertex and one other piece of information, and we had to use that to find A so that we could write our equation. But this time they don't want it in standard form. Yes?
From the previous one, would it change anything if it was like minimum?
If it was a minimum, yes and no. So asking a minimum distance for two things that cross, like right here, the minimum distance between those would be 0. So any two functions that cross on the graph, the minimum is kind of an understood 0 at the places where they touch. So they're probably never going to ask that particular question. Does that make sense? It would make sense if I had maybe a linear function and a parabola that would never touch each other, but I don't believe that that's anywhere in the curriculum. So, all right. What form do they want me to write this in? What form is that? Close. If it was a linear function, it would be point slope form. What would these pieces right here be telling me on the graph? The roots. This is my factored form. And so we're going to look at our roots. What's a synonym for roots when I'm looking at a graph? X-intercepts on the graph. Where are my x-intercepts on this graph? -2 and +4. So -2, 0. And over here at +4, 0. So just like we did with the standard form, with vertex form, I'm going to start off just by substituting in what I've got. So x minus -2, that's going to turn into x plus 2. And x minus 4. How can I use anything else they gave me to find A? Substitute that point in for x and for y. So this guy right here. We're putting 4 in the place of y. And I'm putting 2 in the place of both of the x's. So I have 4 equals A times 4 times -2. What is 4 times -2? -8. So I have 4 equals -8A, which means that A is what? -1/2. That was the only piece of information that we weren't given directly from the graph, so we can take that and substitute it in right here for A. So y equals -1/2 times x plus 2 times x minus 4. All right. And that completely finishes 3.6.
Don't. I like this one. No, don't, because I actually like 3.6 too.
Right. We have one last section in chapter 3. So we're going to start on 3.7 today. We'll continue with it tomorrow. You guys will have a video on Thursday to finish up 3.7 so that we have our in-class review day on Tuesday. Or sorry, not Tuesday, on Friday. Test is on Monday. Today is Tuesday, and so I'm saying the wrong thing. Yes. All right, 3.7, operations on functions. Operations on functions. So some of the basic operations that we're looking at on functions are a sum, which you will often see written as f plus g of x. All this notation means to do is to take f of x and add it to g of x. We're going to line them up and combine like terms. F minus g of x, we have our difference. And we actually just did this on that problem with the parabola and the line where we wanted to find the maximum distance. And so I said we subtract the equation for the parabola and the line. Yes, this is 3.7. That is our difference of two functions. Third one down, what operation do we have going on here? Multiplication. This is our product. So this is just take f of x and multiply it to g of x. And this last one down here is the quotient. We take our function f of x and we divide it by g of x. When we start doing operations with functions, we have to watch out for our domain, acceptable things that we're allowed to use for x. Adding, subtracting, and multiplying, all three of these will have the same domain. And we'll talk about how to find those domains, but these three will all have the same domain. Yep, it can be all real numbers. It depends on what our functions f and g are. If f of x is a square root function, it comes with domain restrictions. And those restrictions would be carried through when we do operations with another function. This one down here is always going to have a restriction with it, or at least something that we need to take into account. What cannot be true about g of x? Yes. G of x cannot equal 0. So any value that would make g of x 0 would have to be excluded if we are dividing those functions. The domain for our new function the result after we perform the operations must be within the domains of the original functions. If it's not okay when they're alone, if that's a value of x that is not allowed when they're by themselves, it is not allowed when you put it together with something else. All right. I want to practice each of these operations and finding the domain, and then we will stop there for today, and we'll pick up with more practice tomorrow. Okay? All right. You guys okay if I put our example up? All right, so we're going to add, subtract, multiply, and divide with these guys. So we have our function f of x. F of x is x squared plus 2. And then we have our function g of x. G of x is 2x squared plus 1. Before I start doing any operations, I want to know what are the domains of these two functions by themselves. What's the domain of f of x? Acceptable things for x. Negative infinity to infinity. All real numbers are acceptable for f of x. We can take any number and square it, as long as it's a real number. What about for g of x? Same thing. We still just have a quadratic function here. I can take any value of x as long as it is a real number and square it. There's no restrictions. All right. So let's add f and g. So I grab my function f of x. That was x squared plus 2. I'm going to add that to my function g of x, which is 2x squared plus 1. What do I get when I add those two together? 3x squared plus 3. Done. What would the domain for this be then? All real numbers. No restrictions on either one of those two original functions, so when I add them together, they don't have any restrictions on the domain. Let's look at the difference of f and g. Have to be really careful when I'm looking at a difference. X squared plus 2, I'm fine to write down, but after my subtraction sign, what do I have to make sure to do? Distribute your negative. So I'm going to pop parentheses in here so that I don't forget to do that. 2x squared plus 1. Distribute my negative here. So I have x squared plus 2 minus 2x squared minus 1. So how will this simplify then? Negative x squared plus 1. What is our domain for the difference? Yes, all real numbers, negative infinity to positive infinity. Remember, for my sum, my difference, and my product, they're all going to have the same domain. So once I know the domain for one of them, I know the domain for those three. All right, let's go look at the product. So fg of x, I'm going to multiply x squared plus 2 times 2x squared plus 1. We're going to need to double distribute here. What is x squared times 2x squared? 2x to the 4th. And then x squared times 1, I just get x squared. I have to distribute my 2. 2 times 2x squared? 4x squared. And 2 times 1? 2. What do I get when I combine my like terms together? 2x to the 4th plus 5x squared plus 2. And our domain. Negative infinity to positive infinity. All right, one more. Last one that we're going to do for today is f divided by g of x. So f of x is going to go up in my numerator. That is x squared plus 2. G of x goes down in my denominator. So 2x squared plus 1. Can I simplify that at all? No. Why not? We've got addition in the numerator, addition in the denominator, so the only thing I could do with this is trying to pull out a GCF or factor it in some other way. Will that numerator factor at all? No. X squared plus 2 has imaginary roots, so it's not going to factor. 2x squared plus 1 also has only imaginary roots, so it will not factor. I can't simplify it any more than this. So that is my difference quotient. Or sorry, not my difference quotient, my quotient of these two functions. But then we have to turn our attention to the domain. This was one that I can't just say it's the same as the other three. What restriction do we have on this? Denominator cannot equal 0. 2x squared plus 1 cannot equal 0. That would make it undefined. So I need to figure out what values of x would do that to my denominator. So let's see, 2x squared cannot equal negative 1 as I try to get x all alone, which means that x squared cannot equal what? Negative 1/2. Is that going to be an issue? It's not a real number. When we're talking domain and range, we're only talking real values. So this is not possible with real numbers. So if it's not possible for my denominator to equal 0, do I have to worry about any restrictions to my domain? Nope. Nothing will make that denominator 0. So we can put anything we want to in for x, so long as it's a real number. This will not affect my domain. Do you guys have any questions for me? if you saw on Skyward yesterday, I did go ahead and bump the due date for 3-6 back a day since I knew we wouldn't be finishing up until today. So 3-6 homework is due tomorrow. Your last homework is due on Friday. If you do not have a copy of the test review, please come and see me. I want to make sure that everybody has the test review.